So good morning students. Let me take up the next topic of the discrete probability distribution, that is Poisson distribution. Now Poisson distribution is generally used when the number of trials is very large and the probability of success, that is P, is very small. So generally, if the example is not specified by which method it has to be solved, that is binomial or Poisson, we see the value of n and then decide to solve by binomial or Poisson. If generally n is more than 25, we go for Poisson distribution. And the Poisson distribution P of x is given by e to the power minus m into m to the power x upon x factorial, where m is the mean of the given distribution. And from that we can also say in a Poisson distribution, the variance and the mean are same, that is equal to m, and standard deviation is given by square root of m. Note that m is the mean of the given distribution. So let me take the first example. The average number of accidents at a particular intersection every year is 18. Calculate the probability that exactly 2 accidents happen in this month. So here, for solving any example on Poisson distribution, we need to find the value of m, which is unknown. So now mean of the distribution m is equal to, it is given that accidents occur every year is 18, and since in a year there are 12 months, so the mean of the distribution is 18 by 12. That gives to 1.5. So once m is obtained, the next is quite simple. So the P of x is given by m to the power x e to the power minus x upon x factorial. Now here for this particular case, x is equal to 2. So m is 1.5 and x is 2. Replacing all these values, we get the probability of exactly 2 accidents in a month is 0.2510 or 25%. Or 25%. And the second condition, calculate the probability that there is at least one accident this month. So please remember, for a particular example, the mean remains the same. So here the mean is 1.5 as we have calculated earlier case, and here at least one accident. Since we don't know the upper limit, we always go for the complement, that is P of x greater than or equal to 1 is equal to, the complement is 1 minus P of x less than 1. As I have told yesterday, equal to sign has to be on only one side. So when I define the complement, we don't have P of x less than or equal to, we have only P of x less than 1. And P of x less than 1 is only 0. So taking this value and substituting, we find the probability of at least one accident this month is 0.7769, or this implies 78%. Now in this example, only 2%, the probability of defective screw is 2% is given. So from this percentage, we need to find the value of P. So 2% implies 2 divided by 100, that gives you P is equal to 0.2. And we know the mean of the binomial distribution is given by mu is equal to n into P. And in the Poisson distribution, I have told mean is the mean of the given distribution. So we'll use the relation of the binomial distribution and we'll find the value of n. So I can take mu is equal to n into P, that's equal to m. So m is equal to n into P, or you can also say this as mu is equal to m is equal to n into P. P is 2 by 100 and I know that n has been given as 100. So your mu, that is mean, is equal to m is equal to 2. Now using all this relation in the binomial distribution formula, I can get the required result. Now this is a classic example of Poisson distribution where you can see that the probability of a bad reaction from a certain injection is 0.001. That is, P is very very small, and determine the chance that out of 2000 individuals, that is n is very very large. So we'll be using the Poisson distribution for this, using the relation n into p, that is mean is equal to m is equal to n into p, where n is equal to 0.001 and p is equal to 0.001 and n is equal to 2000. Calculate the value of m and substitute in the Poisson distribution and get the required result. You can see that more than 2 get a bad reaction. So there was strictly more than 2. The complement will be 1 minus p of x less than or equal to. I have used the equal to sign on only one side. Now here is a classic example on Poisson distribution, where m nothing has been given. We need to find out and then simplify. The question is the probability that a newsreader commits no mistake. Now here the word no mistake is very very important in reading the news is 1 upon e to the power 3. Find the probability that on a particular news broadcast he commits only 2 mistakes, more than 3 mistakes, at most 3 mistakes. Now the given question gives you the value of x, but for the Poisson distribution m is very very important. Now the question is the reader commits no mistake. So if I assume x is equal to the number of mistake, p of x is equal to 0 indicates no mistake is given by 1 upon e to the power 3. Now write the Poisson distribution for p of x is equal to 0, which is nothing but you have only e to the power minus m. So I have e to the power minus m is equal to e to the power minus 3. Equating these two, I get m is equal to 3. Now once m is obtained, for the first case, only 2 mistake, I'll take p of x as 2, put the values, all the values in the Poisson distribution, I get 0.2240. For more than 3 mistake, that is strictly more than 3, since I don't know the upper limit, I take the complement, that is 1 minus p of x less than or equal to 3, and I get the answer as 0.3528, and at most 3 means maximum 3 mistake, so it will be p of x less than or equal to 3, that is equal to, it includes p of 0 plus p of 1 plus p of 2 plus p of 3 so on, that's equal to 0.6472.